Hello everyone, and welcome to our latest State of .NET webinar, the State of .NET Application and System Development. Today, Markus Egger will take a look at the bigger picture of .NET development. How are systems and applications developed? What are the main stumbling blocks? What things make projects successful? If you're wondering how to approach your next or even your current software development project to avoid common pitfalls and instead approach your projects in the way that's most likely to succeed, then, my friends, you are in the right place. My name is Jim Duffy, and I'm responsible for the marketing and sales efforts for all of our code services, including Code Magazine, of course, but oh my goodness, code is so much more than just a magazine. Our continuing mission is to help people build better software, period. We're a Microsoft partner and provide a number of services, including building custom software applications for on-prem and in the cloud, modernizing legacy applications, educating developers, providing developer resources to augment your development team, and supporting and maintaining existing applications. Our team of expert developers and consultants are ready to help you with your next project. One of the very popular free services we offer is called a free hour of code. It provides an opportunity for you and or your team to meet with our expert team to discuss anything you could use our help with. Slots are limited, so reach out to me today about getting your free hour of code scheduled for you and or your team. There are no strings, there's no commitment, no credit card required, just free help from our code experts. We are hiring React developers. Come join the code consulting team. We have multiple junior and senior React positions currently open, remote and on-site. Full-time and contractor positions are available. Follow the link for more information. Looking for a new gig? Check out our jobs page for our open positions. If you're interested in writing for Code Magazine, check out our Writing for Code page for more information. Our code staffing division can help you find the development talent you're looking for to help augment your development team. If you like what you see today or have seen in our prior webinars, please subscribe to our YouTube channel, follow us on Twitter, and like us on Facebook. Code Magazine is the leading software development magazine written by expert developers for developers. All registered attendees who don't already subscribe will automatically receive a free digital Code Magazine subscription. I've also included a free subscription link here for you to freely share with others who couldn't make it to this webinar. Just a reminder that the Code mobile app is available for both iOS and Android. It's the ideal way to read Code Magazine on the go. We would like your feedback about this webinar in the form of a quick survey, and we're willing to pay $100 in the form of an Amazon e-card to one lucky attendee. A name will be drawn from the entire webinar's registered attendee list, and a completed survey is required to qualify for the e-card. If the selected name hasn't completed a survey, another name is picked, and so on. Fill out our very short survey, and don't be that person whose name is drawn only to lose out because you didn't complete the survey. The survey link is on the slide, and we'll post the survey link in the chat window. Just a quick shout out here about Photino. Photino is an open source project that the code team is involved with that allows .NET developers to create native cross-platform desktop applications using web development technology. You can leverage your HTML, CSS, and Java skills to create desktop applications that run on Windows, Linux, and the Mac. It's like Electron, only smaller and much more lightweight. Learn more at tryphotino.io. The slides and recording of today's webinar, and all of our webinars, will be available on the State of .NET page on the Code website. I've included that link here. Our presenter today is Markus Egger. Markus is the big kahuna around here. He's Code President and Chief Software Architect, publisher of Code Magazine, international author and speaker, Microsoft Regional Director, and a very knowledgeable and talented developer. If this is your first time attending one of our webinars, welcome. Thank you so much for joining us. If you've attended one of our webinars in the past, welcome back. Okay, enough for me. Thank you all for listening. Take it away, Markus.
Thank you, Jim. Hello and welcome, everyone. I see we have a diverse group of people signed up from around the world. So good afternoon, good morning, good evening, wherever you might be. Early in the morning in my case. So great to see a big group of people. I know some of you are going to be watching live. Some of you are going to be watching the recording. For those of you that are live, this is a live event. I have my people paying attention to the questions that are being asked online. You may see me look over here on occasion. seeing what questions are coming up and are being sent my way. So feel free to ask that. I'll be answering some questions along the way. And then also probably keeping, if there's too many questions, keeping them towards the end. So let me switch over to my slide deck here. It's not been a while that we've been doing this stuff online. In fact, it's almost the 2-year anniversary of Stata.net Online. So that's pretty exciting. A lot has happened. We've been off the air with the Stata.nets for a while. We've done the last event, I think, in November of last year. A lot has happened since then. We've started a whole new series of webinars, the Code Presents webinars. So don't miss out on those either. Those are also free as always. A lot has happened here on my end as well. Just recovering from COVID to my great surprise. I've been very careful, still got it, so you may hear it in my voice. This is my first time back doing a longer presentation, so I have to apologize in advance in case my voice is a little rough. We'll see how that goes. But anyway, excited to be back. We have an interesting Stata.net today. In a way, a little different than other Stata.nets, and in a way, very much core to what Stata.net is supposed to be. I always tell people when we do Stata.net, the goal that we have is to share our experience and expertise with what we see from development projects for our consulting clients, custom software clients. Of course, we have a lot of clients that we do training with, that we do events like these with. And then, of course, there's all the Code Magazine readers. And we are trying to consolidate all the information we get from that and then share it with you. So what works, what doesn't work, what do people have problems with, what are they very productive with? And this is very much a core session like that. We're not going to see any big code samples, anything like that. I'm just going to share the experiences from a variety of sources, including our own, of course, and the stuff I see as the chief software architect of code. So we're going to be talking about developing systems in a modern world. That, of course, means developing systems with .NET, Azure, but even beyond, because it's not just an Azure and .NET world, obviously. And so there's a lot going on in that sense that I want to share with you. And so the goal is to look at the different technologies and techniques and telling you what you should use when and how that works out. Because there's a million things you can do. There's great best practices, all have their place. But it's also a skill to actually know when to pick these different techniques and best practices. I always compare this to building a bridge. If you're building the Golden Gate Bridge, there's certainly a lot of things that you need to take in consideration, a lot of best practices you can deploy to make that happen. But if you're just looking to build a bridge over a 20-foot creek, then probably not all those techniques are necessary or even the appropriate thing to do. So we're going to take a look at what are the characteristics of successful projects. I'm also going to take a look at what are the characteristics of unsuccessful projects. And a lot of that is, I call it keeping your sanity. In fact, that's, I would say, one of the big strengths at EPS and code is to pick the things that are appropriate. We get a lot of projects that are in trouble. Customers are asking us to step in, take a look, and we are then often able to bring it back to a sane way where you can actually work on your project productively and pick and choose the things that are good for the projects. And those are widely different depending on the kind of project you have. But I can't tell you how many customers that we had that said, finally you came and stepped in and you enabled us to work productively on our systems. And that is what I'm trying to convey today as well. What are the kinds of things that you should be doing? Now, before we get into that, we're going to spend a little bit of time taking stock of where we are, doing kind of a few slides of true Stata.net. Where are we at with .NET? And so let's actually go ahead and let's start out with that. Let me advance my slide here. And one of the big things that has happened here is 20 years of .NET. Unbelievable in a way that it's been that long. In some ways, it's actually been longer than that, because .NET, that wasn't called that, but the first early bits of .NET that we got our hands on were actually back all the way in 1999. I was actually still working on site at Microsoft at the time to some extent. And that's when the public first heard about some of those early bits. We talked about new languages such as C#, which also wasn't called C# at the time. In fact, the code name was Cool, and what a cool language it turned out to be. And the amazing thing about .NET is not just that it's been around for 20 years, but the longevity some of it has had. We are literally still running some of the code that was written with an alpha version of .NET 1.0 and C# 1.0 and even some Visual Basic still. And we're not running this code because it's legacy and we're really needing to replace it with something new and we just haven't gotten around to it. But some of it is still perfectly fine today. We'll talk a little bit today about code longevity and which pieces of code will run for a long time. But we literally have some business logic that was written with the alpha of Cool and .NET 1.0. And now it is actually running as microservices in a Linux deployment in the cloud. And that's pretty cool when you think about it like that. Now, there's other stuff that you can take a look at. If you go to .net.microsoft.com, the homepage right now actually is a page dedicated to the 20th anniversary of .NET, and there's a very cool video that you can take a look at. Is it required watching? Are you going to learn anything that's really going to accelerate your career? Probably not, but it's an interesting look back at what .NET is, what it has been, where we're at now, and what it's supposed to become, with a lot of interesting people talking about how they joined the team, how they got into becoming part of the .NET team at Microsoft. So I would definitely recommend you take a look at that video because it's a very interesting look back. And so that's the 20th anniversary of .NET. Also, Visual Studio, amazingly, is about to turn 25 years old and still very relevant, and with the latest version, got a pretty good facelift and performance boost. And then, of course, we have things like Visual Studio Code. So quite interesting. And cool to be part of something that in a world where everything moves very fast and where we seemingly have the language and the framework and the technology of the week, we have a platform that plays a very important role in the overall ecosystem with all these other things going on around it. But it's been kind of a cornerstone that's been around for a long time. So I'm excited about that. And it's cool to see that not just is it still around, but it's actually growing very rapidly again, as we've discussed in some of the prior State of .NET. So looking at the .NET timeline, of course, we now have .NET 6, which was released on November 9th. We did a State of .NET. In fact, we had 2 State of .NETs about that release. So those are still available as recordings. Go back, check that out. We are now in this predictable roadmap or timeline going forward with the different .NET releases. So we had .NET 6 in November 21. We had .NET 5 in November 2020. Different licenses. One was a general availability. One was a long-term support license. We'll talk about that in one of the upcoming slides here. And we already know .NET 7 is on the horizon, will be released in November of 2022. So it's become very predictable. And this plan that Microsoft had, I've now had this slide up for the last 2 years, probably. My State of .NETs have had this slide almost unchanged, at least the top part, and it's working out good. So this plan that Microsoft has of making this both predictable as well as this back and forth between long-term support and general availability has been working out the way Microsoft wanted. It's been going really well. And we still have minor releases in between, of course, but that's the big picture. So that's nice. Also, .NET 6 is available widely on Azure, has been available widely on Azure with the release back in November. So anything from app services to functions to static web apps to all the different regions to Windows to Linux, all of that, .NET 6 is just very widely available. So that has worked out good. That's kind of the big message about .NET 6. We're all very happy about that, and it's been a good success story. That's highly recommended. So if you're not on .NET 6, I recommend you start adopting that. If you're not on .NET 5 even yet, highly recommend you start adopting it because it's easy to adopt and it's just worked out really well. And if you're already in .NET 5, going to .NET 6 is very, very easy. Now today in this State of .NET, we're going to focus on other things. So this is just kind of part of our quick taking stock of where we are. If you want to learn more about it, first of all, the State of .NET recordings that we did around .NET 6, there was 2 of them still available. Go to stateof.net.com and you can watch them for free, or our YouTube channel, you could watch it for free there. Same with .NET 5. Those things are still very, very applicable, because in a way, think of .NET 6 as a iteration on .NET 5, right? So all the things that were applicable with .NET 5 are still applicable to .NET 6. Also, we did a Code Focus magazine. We don't have any physical magazines anymore. Those were very popular. They're all gone. But all that content is available completely free. I'm not trying to sell you anything here. If you just go to codemag.com/focus, you will see the .NET 6 issue and all the content free. So check that out as well. The same is true for .NET 5. We did a focus issue for .NET 5. These are special issues we do, but we're not just doing those in a vacuum. We're doing those together with Microsoft. So the content that's in there is coming straight from the horse's mouth, if you want to think of it like that. So it's the people that actually worked on the features in .NET 5 and 6 writing articles about it. So it's high quality content, doesn't get much better than the people actually making the stuff, writing articles about it. So all that stuff is available for free online in our mobile app. Take a look at that, go back, watch the recordings. There's a lot of content we've put out. There's also various Code Presents webinars that we've done that you can go back and watch. So tons and tons of content, and it's all available for free. Like I said, I'm not trying to sell you anything here. Now, one of the things we got to talk about here real quick is the end of support for .NET 5. And you're going to be like, what? It just came out a year and a half ago. Why are we talking about the end of support? Well, .NET 5 was a general availability release. It's not a long-term support release. .NET 6 is, and the idea is that you will move into something like .NET 5. It's going to be supported for a while, and then the next big version is coming around, and that's going to be the long-term supported version. So you just flip the switch. So the idea is it has to be very easy to move between .NET 5 and .NET 6, and that is in fact the case. So if you have a .NET 5 application today, as we have a lot of stuff deployed in .NET 5, what we do is, first of all, if it runs, right? You don't have to worry about it. It'll continue running. Now, at the same time, I know that Microsoft will not be deploying patches to, for instance, the Azure deployments of .NET 5. So eventually that may become an issue. So what I do is, next time I work on one of those things, like a microservice or a website, for instance, I just flip the switch to .NET 6. It should really be that easy. And from what we see in our own experience and what we see in the marketplace and what other people see, it is in fact that easy. I've never heard of anyone having a problem moving from .NET 5 to .NET 6. It's just you go into your project, you change the property to .NET 6, and then you deploy to .NET 6. The only thing that might be an issue is if you have a server that doesn't have .NET 6 on it. But then again, if you are on any of the public infrastructure, that should not matter. But even if it's not on it, it's a matter of installing it. So long story short, don't panic. If it runs, it's perfectly fine. But next time around, it's probably a 30-second task to flip that switch and continue on with .NET 6. So that's worked out really well. That's the piece that I want to report here, but it's something to keep in mind, right? And this will continue to happen like this. There will be this back and forth between GA and LTS releases. .NET 7 is going to be another GA release. .NET 8 in a year and a half or a little more than that will be another LTS support. And the GA's releases are supported for 15 months, and then the bigger ones are fully supported for 3 years, and it keeps going on like that. And that's the plan for the foreseeable future, and it's worked out really well. Now, talking about .NET 7, .NET 7 Preview 1 just became available. I think literally like 3 or 4 days ago, Microsoft dropped this. So you can now download .NET 7 Preview 1, run it in Visual Studio, Visual Studio Code, the preview versions of that. So that's interesting, right? The next thing is already around the corner. You can get the preview. What's in that? Well, that's going to be the topic of another State of .NET or 2 or 3, I'm sure. But there's some interesting stuff there. There's more stuff around containerization. We'll talk about that later in this presentation today as well. Containerization is an important topic, and Microsoft's aiming to make that even easier. Currently, if you're building Docker containers, if you're deploying the Kubernetes, it's very well integrated in Visual Studio. So you download the container, the Docker tools. You then use Visual Studio's features to build to that. You may have to do some manual crafting of the Docker files, that type of stuff. And it's not terribly hard, but it could be easier. It could be an experience where you don't even have to download the Docker tools and keep them up to date and all of that. And so that's one of the things that is a big focus of this new .NET 7 release. There's also a lot around WebAssembly. Blazor has become a very popular web development tool. So that's another thing that I can report on, that it's working out pretty good. We see a lot of interest in that. And of course, one of the ways of running Blazor is towards WebAssembly, and Microsoft has been improving that considerably. Now, what is that? If you've never done anything with that, WebAssembly is this binary standard that works in all browsers. It's almost like being able to run assembly code as a standard in all browsers. This is not a Microsoft thing. This is available in every browser that's out there. And so with Blazor, Microsoft has made a .NET version that builds for WebAssembly and then runs native .NET code in WebAssembly. And that's a big theme going forward as well. And it's not just for browsers, but it's also just WebAssembly at its core. How do you build .NET that runs on WebAssembly? And that could become very, very interesting over time for things like IoT devices. So instead of running a full browser with the UI elements as well, it's more just taking the WebAssembly foundation, that runtime environment basically, and then deploying that without the rest of the browser into devices. So that could be very, very interesting, as that opens up a whole new world of IoT and other things. And that's another theme of .NET 7. So there's that sort of stuff. But there's a million other things as well. Of course, there's improvements everywhere in .NET. Performance and this, that, and the other. We'll talk about that at length. It's an interesting release. It's not going to be, uprooting everything again. It's going to be very compatible going forward in a gradual fashion. But lots of cool new stuff coming. So it's not like Microsoft is leaning back and relaxing with what they have achieved. So here's a link where you can take a look at what's in there and check that out. And I'm sure we'll talk about that quite a bit going forward. Let me see if there's any questions online. We'll talk about, I see there's a number of questions. We'll address those towards the end of the presentation. But let's move into the main part of our presentation here today. Let's talk about what makes projects successful, what we see is working in the wild, and what the characteristics are. And in fact, that's how I want to start out. What are the characteristics of successful projects? And in my role as the chief software architect at Code, my role is often to take a look at projects and then see, are they set up properly? Are people able to work on it productively? Are we on a path that'll make the project successful? And what are the main things that I'm looking for there? And it often surprises people, because there's a lot of things that you would think are important for a successful project that to me are kind of second fiddle. They're not totally unimportant as such. You still need to take care of those things, but they're not necessarily the make or break thing. So what are the things that I have seen that are true make or break characteristics? Well, one of them is you need to be productive. It's kind of an obvious thing, but the way the project needs to be set up is you need to be able to work on the project productively. If you have an issue where from day one, your success vector is way too shallow and you are only operating at 50% the speed or 25% the speed and productivity that you thought you would have, obviously that is going to have huge ramifications at the end. Then lack of productivity is probably the number one killer. When I think about, well, what sinks the ship, right? Is it the fine architecture? Is it the testability? Well, all of those are important things, but I've never seen a project fail because it only had 80% test coverage and not 100. However, I have seen projects fail time and time again because it's not productive enough. I've seen projects that were very well architected, that did a very good job at a lot of things, but the team just couldn't move fast enough, couldn't move in a way that kept up with the business requirements. And then it doesn't matter how good your architecture is and how well tested your project is. If you are not being productive enough, that will sink the ship. The project needs to be learnable. If you have a project that you have a team of 20 people and 3 of them work very productive because they learned everything that is to learn, but you have no good way to bring on other people and teach them. It's not learnable like that. Again, that will sink the ship, because if your project ever gets in trouble, you don't have the option to just add more people, bring them in, split the project. Now, I understand that you can't just make a project successful and move productively by putting twice as many people on it. Nevertheless, I will say that that old wisdom that we've had for years in software development, that you can't just add more people, is not totally true to the same extent anymore. It's still true, but not to the same extent. Because in a world where we have microservices, where we split things out more and more, where we have potentially different client technologies from mobile to web to desktop applications to IoT devices, where we have components like AI, projects have become more splittable. So I find it's a little easier than it was. It's still not easy, but it's a little easier to add more people. And as long as the project is learnable, and as long as the project has characteristics where the people that learn how to do it then become productive. The project needs to have an architecture that's capable of adjusting and compensating for problems, essentially. I've never seen a large software project that wasn't hard. I've never have seen a software project where there wasn't hardships that had to be overcome. I always say a successful software project is one where you address the hardships early and figure out a way forward. It's not about pretending you're not going to have those problems. You can plan all you want. There's always going to be the twists and turns and unexpected changes, and people become unavailable, and just problems that arise along the way. And you will have areas where you take shortcuts, and your architecture needs to be able to adjust to that and compensate for that, and in a way make up for it later. So for instance, if you have proper microservice architecture, you have a composable app where you have many different pieces of microservices, and you have UIs and other systems that interact with those microservices. Well, if you then have problems in those microservices and they don't scale very well, or you took shortcuts and there's a lot of smelly, dirty code in there, as long as you have that architecture with proper separation, you can go back and fix those things later, because they become islands that are individually fixable, and you thus give yourself the freedom to make some mistakes and fix some things later. If you have an architecture that's much more interwoven and everything depends on everything and there's no proper separation, and you don't have a proper boundary between your microservices and whatever calls that, well, then it gets difficult, because now as you rip out those services and replace them with the thing that really works, or you go from a simple app service to a Kubernetes system with multiple containers to scale properly, well, if you don't have that proper separation in there, those shortcomings will sink the ship eventually. So give yourself an architecture that allows making mistakes and still be successful. That to me is a huge piece that saved my bacon so many times. And when you know how to do that, that's actually not that hard to do. It's mainly about separation of concerns and having loosely coupled individual pieces. So that's important. Now, this is one that's kind of like, well, that's obvious. You need to deploy the technologies and techniques that match the problem that needs solving. What does that mean? Well, it means that as a software developer and architect, part of the skill, if not the most important skill, is knowing what to use when. I've already used the term Kubernetes. I've used the term Docker Swarm. Containerization is important. But do you really need that? That's an interesting question. Some projects will. And then it's important to understand those things. And every developer at this point, I think, should have an understanding of what containers are. But does that mean every single project needs them? No. I take as an example the Code Magazine infrastructure. If you're in this webinar, you've probably been to the Code Magazine website, or our training and event website, or the Stata.net website. And that website is powered by a fairly large number of microservices on the back end. Do we deploy them as containers? No, we haven't. They're simply deployed as Linux app services. Why? because it turned out that Linux app services were the most cost-effective way to run this, and the scale at which we are at, and thanks to the performance of .NET 5 and 6 and the lightweight nature of a lot of those things, it scales really well just with that. And we did go down the Docker and Kubernetes route in a test scenario, even for that infrastructure at some point. And it would have turned out that it would have been more expensive, much more infrastructure needed, more complex to deploy. We would have needed somebody dedicated to making that process work. And we'll probably go down that route at some point, and our architecture absolutely supports that. But it turned out that in this case, deployment-wise, this was the most cost-effective and still very scalable way to go. And in fact, moving from a Windows to a Linux backend environment to Linux app services that .NET Core, I think we did it first time with 3.1, literally cut our bill into, well, not even half. I think it's like a third of what we used to pay. So understanding how to evaluate that and deploying the thing that matches was a huge part of the success of that project. So again, keeping your sanity, right? The overarching theme that we have today. So these 4 bullet points to me are among the most important. Make a project that's learnable, employ the things that you really need, make sure you can be productive, and give yourself room for error. If you have those 4 bullet points, I think your project will be very successful. To me, one of the things I always like to keep in mind is with this productivity point, the right thing to do needs to become the most obvious and the most easy. That's, to me, as an architect, the overarching guideline that I employ to everything. I try to set up projects where the right thing to do becomes the obvious and the most easy thing to do. I try to put processes and tools in place where you don't have these scenarios where you say, oh, well, it would really be better to do it this way, but I just don't have the time. I need to get this done. Like, make the right thing the easiest thing to do. Create tools, create processes. And if you can't do that, there's probably an issue there. Right, so that's been a guideline that served me really, really well over time, because your team will automatically do the right thing and build better. And then allowing yourself to make mistakes. And also, it needs to be productive for people that learned what they are doing. It's a horrible characteristic if you have to spend a lot of time teaching people, and then even once they know what to do, they are not as productive as they should be. And unfortunately, I have to admit, many modern problems have this characteristic. Like, for instance, we do React development, and this is true for many of the HTML front-ends frameworks. You spend a ton of time just keeping package references up to date and so on. I've always been very critical of that. Now, it's hard to get away from that in those environments. You probably, if you're doing Angular, Vue, React, any of those, you will spend a considerable percentage of your overall project expense and time on people just updating package references, making sure things compile. They come in the morning, pull the latest source base, and all of a sudden something doesn't work anymore, and then you spend an hour trying to fix that, and then at the end of the day you go, well, now it's all up to date. I don't even know why it didn't run, but you still spent that time. That to me is a horrible characteristic of projects. I've been very critical of that in many cases. And I try to steer clear of that as much as I can. That to me is one of the biggest ways of making projects successful. And I understand you won't always be able to do it, but making an effort in that direction to me is very important. Now, what about these other points? You will say, oh, there's all this important stuff you need to consider. Your project needs to be testable. Your project needs to be scalable. You want to get reuse, whether it's code reuse, component reuse, mindset reuse, architecture reuse. You want to employ all these best practices. I'm not saying those are not important. They're still very important. But it's a second level of importance to me. I have never seen a project that failed because we didn't have enough reuse. Yeah, we may have had to scramble. We may have had to do a lot more typing than we wanted. We may have had an extra 10% of work or 20% of work that needed to be done because we didn't reuse components as much as we could have. And we looked back at the project at the post-mortem, And I said, next time we do better. Next time we'll start with a better architecture that allows us to have more reuse. Or we start with better architecture that's more testable, and we'll get much better test coverage from the get-go. Or scalability. We may have started out and the project wasn't scalable and there was more work that needed to be done. But if we give ourselves the leeway to make some mistakes because of proper boundaries, those are things that are fixable. I've never seen a project that had the plug pulled because it wasn't reusable enough. I've never seen a project that had the plug pulled because it wasn't testable or tested enough. I've seen hardships because of those things, and we had to fix it. So I'm still saying this is an important secondary thing. And there's many projects where testing is a perfect example. We have a project right now that we work on for a bank. Well, we don't want to go through a deployment of banking software that potentially approves loans automatically and stuff like that, that isn't tested properly, right? We do need to have testability, and to have testability, it needs to be built in from the get-go. It's very hard to just add that later if you have never thought about testing. But at this point, I'm assuming that most people have that in their mind a little bit, right? So you're creating software that's fundamentally testable, and then you may struggle adding more. So yes, hardships exist, but I've never seen a project completely fail because of that reason. But I certainly have seen projects fail because they were not productive enough, because you couldn't move new people on it, they weren't learnable enough. The fundamental architecture meant that people shot themselves in the foot so badly that they couldn't recover from it, right? So take my prior slide as here is the top level of important stuff. Take this slide as this is the second level of important stuff. Okay. So here we have some connectivity issues. Got a little bit of a low bit rate on OBS going. Don't really know how to start and stop it. I don't think we can do that. So I guess we'll just have to stick it out and hope it gets better again. So anyway, that's kind of that slide here. Now let's also take a look at it from the other angle. And let's take a look at it from the characteristics of unsuccessful projects. What are the things that I sit there and I literally lose sleep about this stuff at night when I think about our projects that have some of these characteristics? To me, the number one problem is, even after we do a lot of training, even after we put a lot of documentation, a lot of processes in place, a lot of mentoring structures, all that type of stuff, the team just can't become productive. So I see we still have connectivity problems online. I see my bit rate has gone up again. So hopefully that was the end of that. Anyway, so teams that just cannot become productive. I see a lot of teams where you have, say, 7, 8 people on a team. You have the leader of the team. The leader of the team works reasonably productive, although not that great. You have another 2 people that can kind of follow along with that. And then you have the rest of the team, and they just cannot function. And nobody can figure out why. The leaders just feel they're stupid. The rest of the team feels the project is set up horribly. And no matter how much training you do, you just cannot become productive. This is probably the number one characteristic of projects that we see that are unsuccessful, where people call us in, customers call us in to do project rescue. This is the number one characteristic I see. And I would not be surprised if a good percentage of the people that are online watching this event now say, yep, that's kind of the setup that we have. So this productivity issue is something you need to solve. It's not gonna get better. If you have this type of issue in your project, you need to take a step back and need to take a look at everything you're doing. Are you really building value, business value, features that are being pushed out and available to users? Or are you just catering towards this project setup where you built this high architecture with all these best practices, but maybe don't even need them for this project, right? So bringing sanity back to a project. I see a lot of projects where even senior developers struggle. This whole setup that I just told you with 8 people, 5 of which can function, those 5 people in many cases are still very senior developers. It's a very, very common scenario. Things that should be common, things that should be used a lot, are not easy. That's a horrible characteristic, right? You're setting up a project and everything you do is just hard. You're adding another microservice operation, another method essentially, that potentially has relatively simple data access or some very simple business logic. And building that is not hard, right? It may be a 20-line operation that takes you literally 5 minutes to build, but putting it all into place takes 3 hours because the whole pipeline, the whole infrastructure is just so complex. And then you try to run it and you have no good way to run it, and you trigger certain things, but the infrastructure is such that everything can go wrong in the middle and you don't really know why, and then it never comes out the other end and your code is never triggered, and you're like, well, it took me 5 minutes to write this, but now a day has gone by and I'm still not sure it works. That is horrible, right? You need to make sure that very common things you do a lot, those things need to be easy, and doing the right thing needs to be easy. I've also seen this a lot, where typically here's what happens. You do a project and it went reasonably well, but it was kind of a death march and you got it done, but you're like, next time we do it all better. And then you look at that and you put all the stuff in place because one day that will be a huge benefit. We're putting all the stuff in place, so if you ever have to go to a different database, it will be easy. If you ever have to add this, it will be easy. If you ever have to scale it, we're already there. We already made the stuff that scales really well, even though we don't need it yet. This nebulous future benefit I have never seen come to fruition in 30 years of software development. Maybe you are the exception. I'd love to hear about it, where you struggled through this unproductive project, but 3 years later, everything worked like a charm and you got all this benefit and you harvested all that investment many times over. That's the idea of this, right? I've just never seen it because 3 years down the road, things are very different. And then this whole issue, I see this a lot, where the project in theory should be fantastic because you've put everything in place that anyone ever told you is best practices. You've watched every state of .NET, you've been reading the Microsoft blogs, you've watched conferences, listened to .NET Rocks, all those things, and you put all those things in place, and theoretically the project should be great, and you're doing all kinds of testing and automated builds, and all the tests run beautifully. It's just, you never have anything to show for it, right? The project as a whole is not coming together. It's very slow in the big picture. You're not achieving your milestones. You're not putting out actual features. The business stakeholders in the project never get to see as much as they need to be. That's not a good project. The purpose of project is not to build high architecture and have 100% test coverage. The idea at the end of the day is to build a system that does something. And people forget about that, right? So that's something I see a lot when I go and look at things. Now, there's some other aspects that we need to talk about. I haven't really talked about security, for instance. Security to me is special. You need to think about security from day one, and you should have a mindset that allows you to build secure code. Security is not one of those things where you can easily give yourself leeway for errors. It's very, very difficult to build security in later. And so you need to have a fundamental understanding of security. It should become second nature for you to not have to think about security and still go about things in a way that can be secure from day one on, because you won't be able to bolt security on later. And this is something where I have seen projects fail. I can tell you an anecdote. We've been working on a project that also had to do with, it wasn't technically a bank, but had to do with loans. And these loans were given online. And the project actually worked beautiful, was productive. It was pretty much done on time, maybe even have been ahead of time. And it got deployed. And within 24 hours, security was breached so badly that literally millions and millions of dollars have been lost. The plug had to be pulled. It was one of those scams where for a while people would advertise on TV, work from home, make $5,000 a day by being a software tester. And these people have been told, go hammer this website, try to apply for loans. And then people got that money and they had to hand the money back, but they really handed it to thieves, unbeknownst to them. And so within 24 hours, this organization lost literally tens of millions of dollars because the security wasn't right. And the plug had to be pulled, and it was a big rework. There was no, oh, let's go fix this and we'll be live again in 2 weeks. If security doesn't work, it can sink the ship, and it can be extremely difficult to fix, extremely expensive to fix. And you just can't make something that inherently takes a non-secure approach and make it secure. So a security review might be a good idea. Ask us. I always tell people, consider us a resource, right? If you have questions about this, send me or Ian or Jim a message, and we'd be happy to answer your questions. We're not the kind of company that will send you a bill for a short answer. It is a service we do offer commercially as well. We do security reviews. But this needs to become a mindset shift if you're not doing it already. Your people should build secure stuff without explicitly thinking about it. That would be the goal there. Now let's also talk about the cloud a little bit. The cloud to me has become one of the main drivers of building successful systems. It's also in a way one of the main stumbling blocks that people have. And it truly changed the way we are building systems on a paradigm level. Many systems have now become cloud native. That's actually, to me, a big enabler. It's so much easier to build many things on the cloud than it has been in the past. Because what you're doing in many cases is you're using very specific things, services that the cloud offers, that you would have had to build yourself in the past. Here's a good example. Let's say you need to trigger things on a schedule. Every Monday, every 3 days, every day at midnight, you need to trigger something. This type of a scheduling engine, if you have to build that in a scalable and truly reliable way, is a non-trivial thing to do. Now, some of you may sit there and say, oh, but I've done that. And yes, you can do that, but it's a task, right? It's not something that you'll just throw together in an afternoon and it works reliably. It's something that somebody needs to do. While being able to just take advantage of, let's say, Azure Functions, or I guess AWS Lambdas, that have a feature built in that triggers on a schedule or even based on other events, and it just works, well, that certainly will remove a lot of stumbling blocks. And using these services has worked out very well for a lot of people. So you can come away from this presentation here with the understanding that using more than just infrastructure on the cloud, but using specific APIs and services has worked out really well for a lot of people. And you could have something simple as the scheduling example, or you could have something very, very sophisticated, say AI and machine learning, which is something you couldn't really build yourself. Or even things like Docker-based containerized systems, large orchestrated clusters, global deployment. You just can't do that yourself very easily. It's not feasible. It's not cost effective, but you can absolutely do that on the cloud. So I would highly recommend, if you haven't done that yet, I'm assuming a lot of you are on the cloud at this point because that's become very, very common. But a lot of people still use just infrastructure. I'm just running a website or an app service or a database in Azure or on AWS. Well, try to go a step further. There's really cool stuff out there. Go back, watch our prior Stata.net where we discuss different services. Check that out. Now, the downside of all this is you now have a strong tie to a specific cloud. So if you want to move, say, from Azure and move your AI logic out of Azure and move that to AWS or some other cloud, in many cases, that's not easy if you're using anything beyond just infrastructure, because it's just different technologies. And if you created Azure Functions and you want to go to AWS Lambdas, that's probably not that easy. And maybe you have some abstract architecture in place where you're really just wrapping existing technology, then that may be a little more feasible, but that's extra effort, right? So a lot of times we see people using features out of specific clouds. And so therefore it's important to understand those options, because again, it could sink the ship if you went with some AWS feature and then there's a strategic decision in the company to move away from Amazon. That could be tough for your project, right? That could send you back to square one in many cases. So that's something to consider. And there's this thing now that a lot of people talk about called the multi-cloud strategy. And you may see that people in the industry talk about, so many of the Fortune 500 companies are using a multi-cloud strategy. And is this something you should do? Now, for one, of course, it's nicer to be able to move between clouds and not be vendor locked. Because if Microsoft hikes their prices and you're locked, well, that could be a problem. Now, they're not known to do that. It will probably not be in their interest because it would ruin their future business, but it's just something to consider. So how could you make yourself more open to multi-cloud strategy? Well, I've heard this compared to being able to do a multi-database strategy, where people say, oh, I'm building for Oracle, but I'm building it in a way where I could easily switch to SQL Server. Well, if you think back in time, how many projects do you really know where that worked out well? Where it wasn't just the lowest common denominator type of thing. We still took advantage of both databases. Well, probably not so many. And if it was a success, which there are products and projects where that is a success, that in itself becomes a job. It's not inexpensive to do that. Okay, so there's a lot of overhead in that. And I think that compares very well to a multi-cloud strategy. I have not seen a lot of projects in the cloud where people literally say, I'm currently running on AWS, but I could move my database very easily to Azure. I'm using Cosmos DB on Azure, but I could totally easily move that to some other database technology and some other cloud. That does not happen very much. Now, things like containerization can help you with that. But again, then we're talking more infrastructure, not the specific services. So what I see in the wild is that a lot of people that say, or a lot of companies that say we are multi-cloud, it's almost by accident. They may use AWS Lambdas, they use Microsoft App Services, they use cognitive search out of Azure, or maybe Elasticsearch out of AWS, because those things just work well for them. And that seems to be a model that works really well for people. Pick and choose the best, but it doesn't become interchangeable. You're not moving. I don't see people that just switch from AWS Lambdas to Azure Functions very easily. So it's what I would call more accidental multi-cloud. Pick and choose the best. Different teams within a company may just go different ways, but it's not so much, hey, we could run on every cloud. And there's some areas where there's regulatory pressure towards doing that, where you can't have a vendor lock. And that's expensive then, because you're doing things multiple times. Now also, when you're dealing with something like that, be aware that there's aspects you just don't control anymore. And this has become a little bit of an issue. You're using certain cloud services, and all of a sudden the vendor says, hey, end the life of this service, you need to move on and use something else, starting whatever, April 1st of 2022. And then you have no choice but to fix that. It's very frustrating to me, because you often have services that may work very well, and you have no problem with them and have no business reason to ever spend any money on that again. But then all of a sudden you just have to. You use, say, a credit card processor on your e-commerce site, and they just say we're introducing a new API and we're dropping the old one. Okay. Or we use something in our magazine business where we are validating addresses with the US Postal Service. Well, US Postal Service dropped that API that they had, and so we had to go in and we had to rebuild that, go into their new API. Now, in that case, it was very easy to do, but nevertheless, somebody had to go into the system. The developer that did that originally may not have been there anymore, so they had to go into documentation. If you have documentation, you set up your system. A day or 2 or 3 is easily spent even on the smallest change, and if it's a bigger change, you may find yourself doing weeks of work. And you have no choice but to do that. Otherwise, your system will stop working. So I find that very frustrating. I find that to be an expense that nobody ever talks about, but I find it to be a very real expense. And I find that as time goes on and we have more and more of these services that we use, the problem gets bigger and bigger. And of course, the biggest issue that you could find yourself with is that the vendor that you use goes out of business. We had a similar issue. It wasn't a going out of business thing, but it was kind of the same sort of problem we had. For some reason or another, had to change the way we process emails, and it was a complete rewrite of our email processing pipeline, and very frustrating because it worked perfectly fine before, but it just became unavailable to us. So that's something to keep in mind, and something that I definitely am losing sleep over. Now here's an interesting other topic that comes up time and time again, and that's what I call code longevity, or the reuse, or how long do you expect your system to be around. And I told you in the intro of today's presentation that we have some code that's been around since the early days of the alpha of .NET. Now the general rule of thumb, I think code is around at least twice as long as you think. Even if you think it's going to be around for a long time, it's probably going to be twice that, and in many cases much longer than that. And then what happens with that is you take on technical debt, and you need to think about that, because you need to at some point pay that back and deal with it. So if you have very old systems, even that example I had, we had to migrate it, and we had to take it out of the old, just use a DLL or use an XML web service to access it, to many iterations. And until we arrived on Linux and Azure as a microservice, and probably will go to a containerized setup at some point. So how do you deal with that? And there's different approaches. I find that this disconnected setup, this giving myself room for error setup, also works very well to then go back to old code and bring it forward and fix it up. However, what's also turned out to be very attractive for a lot of large scenarios is to not even deal with that at all. I have several customers at this point that are amazingly successful. If you would have told me about this 5 or 10 years ago, I would have said you're insane. But it turns out they're surprisingly successful simply by building stuff that's planned to be throwaway stuff. Making services, have a quick, productive way to do so, have a way to test them, deploy them, and then rather than bringing that forward 10 years and modifying it and adding to it, eventually this becomes throwaway, and we're just building more services and we're deploying those. Because it's become so easy to do so, it is more attractive to never pay back technical debt, to instead of maintaining things for a long time, just building new stuff. And I know that large companies like Uber and Netflix employ this technique also at a surprising rate. And so that is something that you can think about, right? Do I really need to create this amazing architecture in my microservices because I'll be using them for 20 years? Or is it better to just say, you know what? Maybe next year we'll build more new microservices, and whether we build them in .NET Core or we build them in Python, whatever, it becomes replaceable, and errors are not being dragged forward for 20 years and need to be fixed at some point. So all of these options are possible, and it depends on your exact scenario. So again, if you have any questions about your setup and how does this apply to mine, we'd be happy to spend a little bit of time with you. I have a slide later in my presentation here, and Jim talked about it in the intro. We offer this thing called a free hour of consulting. We're happy to look at it and make some recommendations as to whether one of those ways is applicable to you or not. Disclaimer, first come, first serve. It's been a very popular offering that we do. So we are at a point where we can't do everyone's free hour of consulting. But even so, you can always send us an email as well. Now, a little bit of a rule of thumb here. It's probably not surprising that the thing that has the most longevity is data, right? So our customer database, for instance, has been brought forward for a long time. We have subscribers in our system, for instance, that were there from day one. Obviously, we don't throw that out. We may have moved the database, may even employ new techniques, but in my experience, it's the part that actually lives the longest and changes the least. We tend to supplement databases. We add things like search services. So we're using, in our case, Azure Cognitive Search, where we mirror some data in. But at heart, Our customer database is still a SQL Server database that uses many of the data structures we've had for 20 years. Now, the middle tier, I would say, and I'm using middle tier, the old term here for the lack of a better term, but any kind of middleware, any kind of API, services, business logic is also around for quite some time. You may deploy it in very different ways. It may be this throwaway piece, but just logically speaking, this is where we see things are around for quite some time. Where we don't see things hanging around for a long time is the UI. In fact, most of the legacy conversions that we do, they are really driven by an outdated UI. A lot of customers come to us and say, oh, we've had the best product in the marketplace for the last 15 years, but we're getting killed by our competition because they just have a sexier, newer UI. That happens all the time. UIs drive code replacement and legacy replacement. So you may find yourself replacing your old WinForms app. That's very common right now. And by replacing an old WinForms app, I don't necessarily mean replacing it with a mobile client. I'm sometimes just saying replacing it with the .NET 6 version of your Windows app. And that's a surprisingly common and popular scenario. But you'll see older UIs getting replaced with something that looks better, maybe a web version, an older web app replaced with a single page modern web application. We see mobile apps, we see hybrid mobile apps getting replaced with dedicated, say an iOS app rather than a web app for a mobile device, that type of stuff. So UIs are by and large the biggest driver for rewrite and legacy conversion. So you want your UIs to be somewhat separate, right? That's a big thing because that'll happen to you a lot. Moving on to a little bit of a different topic that I get a lot of questions for, and that is DevOps. DevOps, everybody talks about DevOps. We've done DevOps data.net that you can go and watch again. DevOps is essentially the process of automating builds. And the answer to do I need DevOps is in many places, many projects you probably do. But it's gotten to a point where you're almost looked down upon if you don't have a big DevOps process. And so the question becomes, well, what is DevOps? And what of DevOps do you really need? Well, DevOps is the whole process that ties your build and project process and infrastructure together. The way you write code, the way you push it into a repository, likely some Git-based thing at this point, possibly GitHub or Azure DevOps. And then not just that, but then automated builds, automated testing, automating deployments into staging and production and test environments, all that sort of stuff. So there's very, very appealing things in there, and you will probably need at least some of that. But be aware that this is another task that needs doing. The step from I'm building on my machine and I just have a Git repository and when we create a build, it's a manual process, and then somebody does some testing, and it's a manual process to push that into production, to fully automating all of that is a big one, because you have to set up DevOps, you have to set up these processes, but also your code needs to be structured in a way that supports that. To have good full test coverage that doesn't require certain databases to be in a certain stage, but you're mocking that and all that type of stuff. Those are all cool techniques, but it will take an effort. You probably need somebody to do that. And I'll be perfectly honest with you, we have some small things, remember those throwaway little services and stuff like that, where we do maybe, sometimes it's just CRUD. Right? How much sleep am I losing over not testing CRUD operations with unit tests? Not that much, because they're probably working. My area that I'm losing sleep over is the connection to the database, those loosely coupled things that are likely to break. Maybe we don't even have DevOps. Maybe they're so small that they're touched very, we don't have daily builds and nightly builds, and it's just some little thing that just somebody pushes into testing, and we do some testing and then push it into production, and we feel very dirty about it, and we definitely realize we are not among the cool kids for doing that. But there is projects where that is by far the most cost-effective thing. And if you're breaking something, maybe it's not that big a deal. Maybe the impact is that one dude in some unimportant department just can't do their tasks for an afternoon and then move on to something else and do it tomorrow. The impact may be very low. There is those scenarios. And it is an important part of evaluating your process to understand what the impact is of those things. But then, of course, there's those other projects that have 10 people working away in this system, and it has tons of services. They're all interconnected, and you need to have a nightly build, and then you can't do that build until you do testing, and testing you can do unless you have the project set up properly, and testing requires data, but you don't want to use a database because it's always in the wrong state, and therefore you need to mock it. And then that goes through a build process that's automated, and then it gets pushed into a certain branch, and then that gets pushed to testing. And when that happens successfully, it gets pushed into staging and eventually even into production. Well, for that, you may need a proper DevOps process, right? And those projects are, of course, very common. And if you're doing something serious, then that's what needs to be done. Just don't think that, oh, we'll set that up and then it's running. It is a task in itself that needs doing, that will cost money, that can go wrong. When it goes wrong, it's often a black box and you don't know what's happening. And so it may need a person or more dedicated to do that, right? Understand when and how to deploy that. So it's not just that you have to go all out. Maybe you can even use part of that process to alleviate the worst problems. I always ask myself, what am I losing sleep over? What is likely to go wrong? Am I automating? Am I testing something that is likely to sink the ship? That's where I want to start, and then grow it from there and see if you're getting the return on investment. So that's kind of the big picture. Now I want to briefly go through some specific technologies here. I've talked about in the past about Azure services that every developer should know. We've talked a lot about different UI technologies. So let me just touch briefly on those and tell me what I see in the marketplace in the wild as working well. Let's start with the front end. We have browser apps. That is probably the most common thing people build today. Spa apps, single page apps, web apps, whatever you want to call them. Apps that would in the past have been a Windows app are now a browser app. Maybe your CRM package, those types of things. What are we using for that? Well, there's several different technologies out there that all work about equally as well. Whether you're using Angular, Vue.js, React, there's several smaller ones, smaller frameworks out there. I would say they all work about equally as well. They have characteristics I don't like. I'm not a big fan of bringing in literally 50,000 files from package managers to do a Hello World app, but that's the world we live in. Okay, I try to eliminate dependencies as much as I can because I figure, in my experience, that's what the biggest nightmares are. That's where in the last 5% of the project we are almost done, and I just need to push this one more thing out, and then you spend a day trying to untangle package problems, right? But that's the world we live in. We have those types of technologies, and I would say they all work about equally as well. We do a lot of Vue.js projects. That seems to be our go-to framework of choice. That seems to work the best for an average project. We also use a lot of React, a lot of Angular. So we have all those camps in our company. And it's just slightly different characteristics that different people like for different things. Also, Blazor seems to have been going very well. To me, Blazor is a framework that's very well architected. I like the structure of it. I like that it eliminates some of those wild and crazy package references. I find we're doing less in terms of untangling build problems and all that and focusing more on development. I like that. Now, Blazor you can use in different ways, whether that's WebAssembly in the browser, whether that's server-side, that seems to be split. But all those things seem to be going well. Blazor developers are in demand, right? It's just something that seems to be going pretty well. Also, traditional server-side development with ASP.NET MVC is still going well. If you're building something that's more a site than a single-page app where you're logging in and now you're in the app, right? But it's more a site, like imagine codemac.com where you're jumping from article to article. I'm building that with ASP.NET MVC. It's a .NET 5, .NET 6 world now, of course, but those techniques are still very applicable to that, right? So all those things fundamentally work well. I wish I had some things to point out. It would be like, oh, well, React doesn't work well at all, right? No, they all work about equally as well. I always feel web development should be so much better than it is. People that know me know that I've been vocal about that. I feel we're not in a world that's as great as it could be for web development, but it is what it is. And most of these things seem to have very similar characteristics. Let's talk about mobile apps a little bit. That's an interesting aspect. And when you build mobile apps, you have really two approaches. One is build once, run everywhere. And by run everywhere, we basically mean iOS and Android at this point. Or build separately for these two platforms. And when we say build separately for the two platforms, most people are like, oh my God, that's going to be a lot of work. We don't really want to do that. Let's build it once and run everywhere. However, in my experience, now that we've done that for years, I would say don't expect a lot of magic from number one. There's a lot of cross-platform technologies, whether that is things like React Native and similar efforts that you can use. There's also things like the Maui Xamarin stuff. Maui, by the way, still not released, but getting close to a release candidate. That's Microsoft's application platform for cross-platform apps built on top of Xamarin, which will build iOS, Android, but also Mac and Windows applications. That is a very interesting development. We'll see how that goes. But to be honest with you, for most development, like say you take a look at the Code Magazine mobile app, we are building two apps. And we are building two apps because we've come to the conclusion it's easier and less effort to build two apps than to build cross-platform apps. To me, the one technology where that may not be totally true is Xamarin. Xamarin's pretty cool, but I've had this project that this wasn't something we did, but a company that we are friends with built this project where they had spent 6 months on building a React Native app that runs cross-platform on iOS and Android, and it had a severe productivity problem. So that characteristic I don't like. And then the lead developer on the project bet the owner of the company that he could do everything that they'd done in the last 6 months in Swift just as a native iOS application. And in fact, he won the bet. He was able to do more in 2 weeks than they'd been able to do in 6 months in React. And so they shifted to a world where they're building their native apps in Swift for iOS and in Java for Android. Java is still a good choice there, although there's others like Kotlin that are pretty good. But they're now building that in two separate silos. They're building the Swift app, and then they have somebody who basically replicates in Android everything that was done in Swift. And they are far faster doing those two things than they were trying to build one app that runs everywhere. And the result is superior because now they're truly handcrafting for the individual devices. So that is something that I see quite a lot. Now, that may not be true for every single scenario. So it takes some evaluation of what to deploy. But in my experience, two separate efforts don't necessarily equal double the work. In many cases, it's actually the opposite. Okay. So Maui, I already mentioned that. This was supposed to be released, I guess, at some point with .NET 5. That was unrealistic. Then it was supposed to be .NET 6. That didn't really happen. But now we are seeing a release candidate for Maui, and that should become available, and even the release apparently should become available in the .NET 6 timeframe, so prior to .NET 7. We have no idea yet how much of an impact that will make. It's a promising approach, could be very interesting. We'll have to see how much the community takes to it, but it's a cool thing, this Microsoft cross-platform rich client thing that grew out of Xamarin. I'm sure we'll do Stata.nets about that in the future, and Code Presents and many articles in Code Magazine. So that's still coming. Now here's another thing. Front-end development on the desktop. It's something that people always talk about very little. It's certainly not the cool thing that you hear about in a keynote presentation or anything like that. Nevertheless, in the wild, we see a ton of people doing desktop development, whether that is WPF, whether that is WinForms, whether that is any of the WinRT style development, maybe not so much there, but there certainly is an impact that WinUI makes. And now with Project Reunion, or the Windows App SDK as it's officially called, all those Microsoft desktop technologies are being brought back together. And whether you have a WPF or a WinForms or any other project, you can use all those technologies within your app. Even if you had, let's say, a .NET 4 WinForms app that was brought forward for a long time, you can now move that to .NET 6 relatively easily, and you can then bring in WPF components, you can bring in WinUI components, fluid animations, all kinds of stuff. It works surprisingly well. And this is something that we see a lot of interest in. In fact, the second most attended Stata.NET event we've ever done was on desktop development. Number one, by the way, was Blazor. But this is really, really productive. A little bit of a related topic here. This is kind of a marketing slide. This is, I guess, the only place in this whole discussion where I'm trying to sell you something. We have, because of this demand, scheduled a training class for desktop training where we teach people in a multi-day hands-on class how to do development for Windows Desktop with WPF, WinForms, and all those other things, Project Reunion, Windows App SDK. We haven't quite announced it yet, but the announcement is imminent. It will be probably in the April time frame. And it'll be a class that will most likely still be remote only. That's the holdup right now. We're trying to decide, should we do it in person, but probably not. But that is a paid training class that we are adding to our training lineup because this has become it's something that's very popular to everyone's surprise. So that's coming up as well. All right, moving along. Pretty simple stuff here. API services, cornerstone of most modern applications. Works out really well. We've done Stata.NETs about that. Microservices all the way. Keep it small, keep it simple, keep it disposable. Keep it where you can throw it away, replace it. You can deploy it in app services, containers. We got serverless computing with AWS Lambdas, Amazon Functions. So lots and lots of stuff there. You can go into containers and Kubernetes if you want. So having an architecture that allows for that is not just smart, it's also easy. And it's usually a productive way to do development. And it's a great way to give yourself that leeway for errors. So microservices all the way, that's working out really, really well. Let's talk a little bit about data persistence. This, I feel, is the area that we need to talk the least about because there just isn't that much movement, right? It works perfectly fine. You got things like SQL Server. We're using Cosmos DB a fair bit. That has some cool advantages. We're using blob storage for anything that's non-structured and binary. Works really well, is very inexpensive. And we're doing this for anything from storing images to doing things with DNA and storing very, very large amounts of data that way. So that's a great way to go, very inexpensive. But then there's also things we add to data persistence that's worked out really well and I recommend using. For instance, Azure Cognitive Search is a way to take your data, create an index, as they call it, which is kind of like a table in the search world, push your data into that, and then you get very advanced search on that. And we did a Stata.NET on cognitive services and AI. This is part of that. It's a smart search. And you can actually kind of use it as a database. Like you could literally just make a search index and that's all the data you have. We have some projects like that where we use search as a database and only ever access them in a search way. And you can run kind of queries on it too. So that's worked out really, really well. I would highly recommend that. So that's it for databases. Not really much new there. The one other thing I want to mention, blockchains used to be the big topic not that long ago with cryptocurrencies and all that. And then it kind of became a little quiet around that. It seems blockchains are silently making a resurgence and are now being rolled out a lot more and end up becoming a real thing. And blockchain technology is moving into things like SQL Server, where you can have tables that are based on blockchain technology. That's in the upcoming version of SQL Server. So interesting developments there. But not anything earth-shaking where you'd be like, oh, I have to reimagine how I do my data, right? That's relatively static. Okay. Let's take a quick look at the list of services I've talked about in the past that every Azure developer should know, and just telling you what worked and what didn't work. We got app service. We talked about that, right? Just deploying essentially web applications. Works out really well. Linux works out really well. right? I'm not coming from a Linux background. I'm not the most likely person to move into a Linux world if you want to think about it like that. Nevertheless, we've embraced Linux because with .NET Core, it works awesomely and it's simply a lot cheaper, right? So I would encourage you to look at that. What do you need to worry about when you do that? Well, with .NET 5, 6, Linux is almost a given. You may be reaching out to some third-party things or specialized components that don't run on Linux. Like for instance, we have one microservice that uses a payment API for credit card processing that just wasn't available on Linux. And so we couldn't move that to Linux. But by and large, it's a really easy thing to do that works out really well and makes projects successful. We talked about SQL Server Databases in Azure. The thing that works best for us is running SQL Azure. You could always run SQL in a virtual machine, run full SQL Server, so to speak, or like a local SQL Server install. You could run that. Much more expensive than running SQL Azure. Okay, so SQL Azure is what works the best for us. We use that for all kinds of things. It's still our go-to database for many things. We use things like Cosmos DB as well for less structured data. But SQL Azure is working out very well for us, and it's something we go back to time and time again. So there's that. Mention that. Storage, blob storage, geo-replicated storage, hot storage and cold storage, which is basically how reliable and how performant is your storage. If you have files that are large that you don't access very much, you may be able to put them into cold storage, which is cheaper yet. And we've never had a problem with cold storage reliability. So that is something I highly recommend you use, works well. Azure Functions is something that also works out very well. It's think of it as small pieces of functionality that are running either as services, so it could be used as an API, but it can also be used to be triggered by a number of things, whether that's timers, whether that's queues that take in data. It's a great thing to use for simple jobs, for simple services. You only pay for what you use. The only downside of Azure Functions, and the only reason why we don't use it for all our services and APIs, is there's a cold start penalty. If you have something that doesn't run all the time but needs to be quick, the first hit may take a while, and that may not be all that great. Kubernetes, here's a very interesting service. Taking containers and orchestrating their deployment and making large container systems. Really, really cool service. Lots of stuff building on top of it. It's become the de facto standard for container deployments. This will get a lot easier yet with .NET 7. That's a big focus of .NET 7. Works out really well. It is, however, not needed in every project. And if you do deploy a Kubernetes setup, it's usually involving more infrastructure than just app services. So if you have small services that are tiny islands that you can just deploy as app services, as in our case where we deploy to Linux, turned out to be much cheaper than building a large Kubernetes system. Now Microsoft's going to tell you use Kubernetes for everything because it's a cash cow for them. And it's a good cash cow. If you need to go beyond that basic service, this is great. It works out really well. I highly recommend it. I highly recommend it's learning about it, just so you know how it works. But it doesn't need to be deployed for everything. Learn when to deploy it. But make architecture, and this is really easy in .NET, where your microservices could be deployed into containers and Kubernetes ultimately. Cosmos DB I want to mention real quick. We use this a lot when it's not real structured data. For instance, we're doing a project for a school, or a product for schools, I should say, that consolidates all kinds of data. And the data could be vastly different and want to be open for all kinds of stuff. NoSQL database is a great solution for that. And Cosmos DB has been working out great for us for that. It has limitless scale. It's from the ground up built for the cloud. Works out really well. So if that's what you need, highly recommend Cosmos DB. And then finally, cognitive services. I don't have time to talk about this today at length, but cognitive services, call it AI, call it machine learning, but the set of cognitive services Microsoft makes available, from computer vision to speech processing and speech recognition and speech output to language processing, the search that I mentioned, do all kinds of other stuff you can do with machine learning today. This is a great way to get into it. And it's hard to imagine an application or system today where you couldn't come up with a scenario where AI and machine learning would make the app better. Whether that is even things like, imagine what we as developers do every day, typing in Visual Studio, the IntelliSense is now driven by AI, right? Those types of things that you wouldn't have thought of before. And so you should think about that. Cognitive services AI is probably one of the most important developments we currently see in the industry. And your competitors will be thinking about AI and making things better with AI. So you should think about that. We'll probably do more Stata.nets and Code Presents about this in the future. I just wanted to mention that here. Will it sink the ship to not have AI in your project? No. So in that sense, it doesn't fit into today's presentation very well. But nevertheless, it's an important topic that you should always think about. And I know there's questions online. I'll be getting to them in just a moment here. Anyway, that's the gist of my presentation. I'm hoping this helps you making your projects better and more successful and avoiding pitfalls. And again, keeping your sanity. You don't need to deploy every tool in the arsenal every time. Learn when to use what and be able to have a learnable, productive setup. That's the key takeaway from here. Now, a few other announcements. Survey. I think somebody mentioned this URL is wrong. We'll send out a new URL after this, but please help us out here. It's tremendously helpful for us if you tell us what you like and don't like about these events, what topics you would like to see in the future. Help us out, let us know. This is important enough for us to give away an Amazon gift card. And we usually have a fair number of people filling out these surveys, but it's not thousands, so you have a pretty good shot at winning this gift card. So that would really do me a big favor if you helped us out with that. Now we got some other webinars coming up. As I said, we're doing this Code Present series now, where we have additional webinars. Since Data.net was so popular, we started this, and it's also been very popular. So we got two that we announced, one about Power BI and another one about VS Code. So those are coming up relatively soon. You can sign up for free, no strings attached. We also have this desktop development training that I mentioned before. I want to mention that here again. Watch for announcements on codemag.com/training. This will likely be in April or thereabouts. And it's a real training class about all of desktop development. So the new world of desktop development, how do we bring it all together? Because we've seen a lot of demand. It's a little bit of an experiment. So we're trying to do that again. Check it out. Code Magazine, I haven't talked a lot about that. We're excited about it, needless to say. If you came to this presentation, you will get a free subscription until you tell us not to. But feel free to share this link. It's an effort. It's kind of a labor of love for us, a fun thing to do. Help us share the word. Tell people to go and they can get a free subscription here. Another thing I wanted to announce is we are currently in heavy hiring mode. We are hiring on all fronts. We are hiring .NET developers, Windows developers, web developers, React, but also other web developers. We are hiring managers. We are hiring even recruiters. Check out codemag.com/jobs. Fun environment to work in. Come work with us. It's a cool setup. So check that out and tell your friends. Again, I mentioned this a few times. If you came to this presentation and you're like, oh, well, this is all nice and good, but I wonder how this applies to us specifically, you're entitled to a free hour of consulting. Limited capacity because this has been popular. First come, first serve. Contact either Jim directly or info@codemag.com to set this up. You don't have to give us a credit card. I mean, this is just a free hour to just look into your specific needs. Mobile app, we've already mentioned. Make sure you tell everyone about that. The cool thing, we have a free subscription offer in there, so all the content is still free. We said we're going to do that while the pandemic lasts, so this has been ongoing for 2 years. We're going to continue to do it. And also, if you're a Microsoft customer and you don't have Code Magazine yet, or one of your friends doesn't, Microsoft is buying people a subscription to Code Magazine. So If you're Dev Essentials or Visual Studio subscriber, former MSDN benefit, you can go to the Microsoft website and you can claim your Code Magazine subscription completely free of charge, including print subscription. And that's it. Thank you very much for attending. Used more than my time allotment there. And I still have some questions to answer, so I'll officially end it here, but I will stay here and I will go through the questions and start going down that list. So a question online is, somebody started a project with .NET Core 1.0 and upgraded to Core 2.0. How compatible are things? Actually, things are very compatible. If you're already on .NET Core, then the upgrade path should be very straightforward. I wouldn't expect any issues there at all. We'd have to look specifically, but I think for the most part, you could probably just forward the target version number and be in good shape. So another question here about logging. Logging was completely replaced in .NET 6. That is true. So with the whole new dependency injected way of doing things in .NET 6, there's a new logging framework. Personally, haven't used it much because we got our own logging framework. So not the ideal person. If there's any specific questions, I can get you the answer though. Send me an email. Another question about GA versus long-time support version. Why do we need to implement GA? So basically the question is, why would I ever go and get, say, .NET 5 if it's not long-term supported and .NET 6 is? Well, .NET 5 is still supported. You get all the features in .NET 5. So if you were stuck on .NET Core 3.1, .NET 5 was very appealing and very cool. Why wouldn't you want all those new features that make you more productive? The system is more performant and you are fully supported. So it's not reason to not go to it. It's just that when .NET 6 came around, Microsoft told you to flip the switch because it's just a lot of effort for them to support so many different versions. So the long-term support is only every other year, but it's easy to move forward. There's no reason really to not go to .NET 5 just because it's not long-term support. There's a question about what framework will be emphasized in the desktop training class. I guess the question is this about code framework or whatever? It's a generic class. So we are talking about how do you generally develop desktop applications today. We're not using a specific framework. Now, we will show some examples, some real-world examples where we use things like code framework and explain the ideas behind it and how to use either that or just the same ideas without the framework. But it's not about a specific framework. The question about SQL Azure, SQL agent jobs, and SSIS packages. To be honest, I'm not the guy to answer that question. Feel free to send me an email about that. I have people that are the right people to answer that question, so I can get you an answer on that. And there's another question, final question, is there a significant cost savings using SQL Azure versus running SQL on a virtual machine? And the answer is yes, absolutely. So what we did is when we migrated SQL to Azure, and some of you may know this, we had a major ransomware attack 2.5 years ago, and it became very pressing for us to move all our stuff to Azure. We moved to a SQL Server instance in a virtual machine because there's some features that SQL Azure doesn't support. In our case, it was that our database had text fields in it. So the old SQL text type that's not supported on SQL Azure. So we had to migrate that into virtual machine instances, and that was, I think, 3 times as expensive as it is now. That we moved to SQL Azure. And it wasn't a very hard move. We just had to fix some of those field types and really no coding changes. But it had to be done, right? So for a while we were on a virtual machine, and then we moved to SQL Azure, and now we're paying like 1/3. So it's much, much more cost effective. What about security in Windows 11 versus Linux? Well, most of the security, not sure what the exact question there is, but most of the security that we are talking about would be more like, how do you secure a microservice? How do you make that secure out of the box, right? Or how do you secure a web app? Do you do multi-factor authentication or just logins and all of that sort of stuff, tokens, and that's not really Windows versus Linux. That is just how you architect your application. So the only areas where we're really talking about, say, Windows security is when we're building desktop applications, right? And then that's just Windows, I guess. I'm not sure what the exact question is there, but most of the time there's no difference in if I think of the right thing of what this question might be, there's no difference between Linux and Windows because you're talking more about OAuth and stuff like that. So anyway, that was the last question. If you have more questions, feel free to email us. I try to answer every email I get. I'll also admit I'm way behind on my email. Has become very ineffective for me. So send it, if you need a quick answer, send it to either Jim or Ian or info@codemac.com. That goes faster. But I will eventually get to answering a question. If you want to send it to me directly too, it'll just take a little bit longer. So with that, thank you all very much. Hope you got some value out of this. And we will see you again at the next State.net, which we'll also announce shortly, but it's going to be every 2 months now. So expect that to happen in late April. So thank you very much and see you all next time.